Good evening, everybody. Obviously, with what he said there, you know I've been a ham for a little while. And actually, I got in it at about I took my novice test when I was 15, but back in those days, the license took 6 weeks to come, so I'd turned 16 by then. And I did get my dad in it. He was retired on disability, and he used to bootleg my calls while I was at work. And I finally made him go get his own ham license. So, but anyhow, we're going to talk about something today. But before I go any farther, while I have your attention, there are two things that hams do that drive me crazy. One of them is 73s, old man. It's not 73s. It's 73. 73 means best regards. When you say 73s, you're saying best regards. Okay? Yes. And secondly, this is W1ABC for ID. Why else would you say your call letters except to ID? Okay, so I got those off my shoulder, all right? Okay. Yeah, there's a bunch of others, but those are the two of them that really drive me crazy, okay? So, we're going to talk about decibels. I forgot to do something I have to do very, very quickly here, okay? Part of my presentation as soon as I can find the darn thing. Nope. I have everything I need. Did I get it? No, I didn't catch it. I'm sorry, I didn't prep good. There we go. Hold that for a minute, Bill. Roger, old man. Name here is George. You're about 20 dB over S9 on this Scotch S meter. What did he say? What does it mean? I'm going to change some ideas that you think you know about that are wrong. I'm going to pop a few ideas for you. And there's the balloon. Okay, what does 20 dB over S9 mean? What's S9? What's a dB? First, let's define a dB, a decibel, named after Alexander Graham. Okay, it is a two-word definition. A ratio. That's all it is. 2 to 1, 10 to 1, doesn't matter. And all dBs are the same. They add, they subtract, okay? Whether you're talking about dBs in power, and you can convert watts into dBs. Antenna gain, line loss for your feed lines, path loss, they're all the same. They all add and subtract. But if you put a letter after dB, you now have a measurement. Measured reference to something. dBW is a watt. Okay. dBm is a milliwatt. dBmV, a millivolt. dBk, kilowatt. dBi, now we're going to talk about antennas for a minute. dBi is reference to an isotropic point. dBd is reference to a dipole. A dBi is an imaginary, dimensionless point in space. You can't make one, you can't buy one. And dBd, of course, is reference to a dipole. There is about 2.15 dB difference between isotropic and a dipole. There used to be a saying about liars, damn liars, and statisticians. Well, Jay says there are liars, damn liars, and antenna manufacturers' marketing departments. When you go to take a look at something, like buying a new antenna, and you got the catalog for this guy's antenna here, you got a catalog for this guy's antenna here, and you know, they look like they're just about the same. But one of them's got a couple dB more gain than the other one. Why? Because one was measuring it in dBi, and the other one was measuring it in dBd. That's why. So when you're looking at the ads, see what the reference is. The odds are when it just says dB, it's dBi, because the marketing department wants the biggest numbers that they can get. There is a manufacturer, I won't say who, in addition to this, adds a little something else. In theory, if you have an antenna exactly 1/2 wavelength above a perfectly reflecting Earth, the signals off the Earth will come out back in phase again and give you, in theory, 3 dB extra gain. This manufacturer in their ads includes that 3 dB in their ads. Now, down at the bottom, there's a disclaimer, okay? That says you have to have a perfectly conducting Earth in order for this to work, okay? All I'm saying is, watch out for the antenna manufacturers' marketing departments. Problem is, technicians and amateurs think in watts and microvolts, but engineers think in decibels. Let's talk about what we talked about here. S9, what is S9? S9, by convention, no law, no rule, no standard, by convention, is 50 microvolts across 50 ohms. That's the back port on your antenna, or your radio. Therefore, 20 dB over S9 is 500 microvolts across that 50 ohm connector. How did I get there? You got S9 on your microvolts, although the real old receivers, which you probably never find, are 100 microvolts. But convention is, besides 50 microvolts for S9, one S unit by convention is 6 dB. So 20 dB over S9 is 10 times, got to look at the formula here in a minute, or 500 microvolts. The formula for power is 10 log of P1 base 10, of course, for you mathematicians. Okay, P1 over P2, power, of course, in watts. But the formula for voltage is 20 log of E1 over T in volts. Note the difference. We're going to need these formulas in a little bit. Now, let's just take, if I can steal this chair for a few seconds here. Okay, let's take an increase of power from 10 watts to 20 watts. You got an old 10-watt radio in your car, and you're going to go out and buy a new radio, and you see one to use at the Ham Fresh for 20 watts, and you say, well, boy, that's a good deal, because it's going to make me a lot stronger, give me a lot more range. Turns out that 10 times the log, or 10 log of 20 over 10, 20 watts over 10 watts, is 10 times the log of 2 over 1, and 10 times the log of 2. The log of 2 is 0.301. 10 times the log is 3.01. So basically going from 10 watts to 20 watts, we went 3 dB increase. You just doubled the power. You got only 3 dB. Now let's do it backwards. Okay, basically 10 times the log of 10 over 20. Okay, you go down through the math again, and you got minus 3 dB. Makes a lot of sense. You double it, you get plus 3 dB, you have it, you get minus 3 dB. 10 times the power, turns out, is 10 dB, because 10 times it turns out that the logarithm of 10 is 1, and 10 times 1 is 10, so it's 10 dB. However, if voltage is doubled, you gain 6 dB. So 10 times the power is 20 dB. So there's the formula, 20 times E1 over E2. And this is the part that catches people. Let's take a repeater receiver that has a sensitivity about a half a microvolt, which is a pretty standard signal level that gives you a relatively noisy but useful signal, half a microvolt into the repeater. So if you want to, you're gonna get out there and you want to put a stronger signal in, so you got a nice quieting. What guys, you'll run here into them, say DFQ, dead full quieting signal. And 1 microvolt won't give you a dead full quieting, but it'll give you a pretty quieting signal, okay? It's 20 times the log of E1 over E2. So you got a 20 times the log of 10 over 5, 20 times the log of 2, okay? 20 times 0.3 turns out to be 6 dB. What did we say? Whoop, went too far. I don't know if I can go backwards out. Well, maybe I'll go on. Okay, the secret is it takes a doubling of power twice to double the signal voltage at the other end. That's the part that people forget about. So you got from 10 watts to 20 watts is 3 dB. Now if you go from 20 watts to 40 watts, that's another 3 dB. And remember, 6 dB is double voltage, or it is 1 S unit. Now, let's just say here, you got a 25 watt radio in your pickup truck, and you go to the Hamfest and see a guy who's got a 30 watt radio, and it's got a pretty good price on it. So you decide to go ahead and buy it and going to put it in your truck, and you go in and do all the work of taking the old radio out, you put the new radio in and so on, and you go out and start talking to some of the guys on the repeater. What's the difference? If you had a half a microvolt signal before, with 25 watts, which will you be with 30 watts? So let's go ahead and do this one. 30 divided by 25 is 1.2. The log of 1.2 is 0.079. So 10 times this number is 0.79, or less than 0.8 of a dB. And it turns out that the difference is from 0.5 microvolts to 0.54 microvolts. That's the only difference that you made. Let's talk about HF here for a little bit. I got to go back here before I get into HF, because I had another couple comments I had to make. Back many years ago when I was a sales manager for Motorola, I had a salesman that worked for me up in Iowa. And he wasn't a ham or anything like that, but he would bust his backside to try to sell a 45 watt radio as opposed to a 30 watt radio. I mean, he'd really work it. And I kept telling him, it doesn't make that much difference. Excuse me a second, fellas. Let's see what it is. KB0DYP, my youngest son. He can wait. Okay. This is way back before cell phones, and this was back when pagers were going strong. And we were up there, and we actually took and put a 100 watt base station on the top of a hospital and put a 6 dB gain antenna on it, and had one of the field engineers up there. And we took one of Motorola's new Pageboy 2s. If you remember back years ago, the thing was about that wide. It was about twice the size of a Zippo lighter. Okay, and we're driving around, and we have the engineer up there page us, and we'd see if the pager went off. Now I sat down with him and said, 100 watts, 6 dB gain antenna, that's 400 watts effective radiated power. 100 watts to 200 watts is 3, 200 watts is 400 watts, another 3, 6 dB gain. Yeah, he understood that. So we were driving around, and I decided I'd have a little fun. Well, I had a walkie-talkie with me on that frequency. So we got into where I could get in with a walkie-talkie so I could talk to the field engineer. And I said, give me a test page at 100 watts. So he did, and the pager went off, of course. I said, turn it down to 50 watts. So he adjusts it, turns it down to 50 watts. Give me a page. And the pager went off. I said, turn it down to 25 watts. So he turned it down to 25 watts. Set a page, the pager went off. Turned it down to 12.5 watts. He turned it down to 12.5 watts. and of course the pager went off again. I'm going down, if you notice, every time I do this, 3 dB at a time, 3 dB at a time, 100 to 50 to 25 to 12 and a half. I said, go down to 6.25 watts. He called back on radio and said, about 7.5 watts is the lowest I can get it. I said, okay, page me. So we paged, and the pager went off. And my salesman was absolutely amazed that at 7.5 watts, the thing worked just as good as it did at 100 watts. Where were we here? I bumped the thing all over again. Hang on a second, folks. Let me get back to the beginning. Okay. Let's talk about HF for a minute. If your S9 with 100 watts on HF, what will your signal be with 10 watts? Well, actually, it's 10 dB down. 100 watts to 10 watts is 10 dB. Answer? About S7.5. What about 1 watt? Answer, another 10 dB down, or about S5.8. What about 1/10 of a watt? Well, you're still about an S4. Now you know why the guys play around with QRP, don't you? Okay? Back many years ago when the bands were absolutely wonderful, back in the late 50s and early 60s, there was actually a story in one of the magazines where some guy over in the Mideast somewhere or other didn't have a ham radio. He had a receiver, but he didn't have a transmitter. But what he did have was a signal generator. And he actually put an antenna and hooked it on the signal generator and put the telegraph key in the antenna wire. And he actually made a contact, okay, using the power of a signal generator, which is probably much less than 1/10 of a watt. Okay. Just to show you that low power does work. If that's the case, if you're S8 with 100 watts, what'll you be if you have 200 watts? There's a couple of radios out there that sell 200 watt transmitters or transceivers. The answer is from S8, you went to about S8.5. How about 400 watts? Remember, from 100 watts to 400 watts, what is that? 6 dB or 1 S unit? You're now up to S9. How about 1,600 watts? You know that guy down the street, okay, that hit the lottery, and he went and bought one of those $4,200 fancy 1,500 watt output amplifiers that does everything but run the flag up and down. What did it do for him? You're now 6 dB over S9. So all that money didn't go very good. Okay. By the way, something that I wanted to say, and I forgot about it here, is that when we were doing 6 dB and 10 dB steps, that also applies to AM and FM broadcasting. Okay, 1,000 watt AM transmitter. Okay, go to 2,000 watts, what do you get? 3 dB. 4,000 watts, 6 dB. Till you get up to the point, 10,000 watts. 10 dB is 100,000 watts. The next step to get another just 10 dB is 1,000,000 watts, and of course you can't run 1,000,000 watts. Okay, you can only run 50,000 watts on AM. Okay, and you know, or a broadcast transmitter, they'll run a 500,000 watts ERP, but a lot of that's antenna gain as well as actually power. Okay. We're going to go on back here. Assume it's 25 watt transmitter here is an S8. To get an S9, what do? Again, the answer is 100 watts. You can't go to 30 watts in matter. You can't go to 50 watts. You can a little bit, that'd make you 3 dB, 100 watts. 100 watts to 1,000 watts, again, 10 dB. 1,000 watts to 10,000 watts, 10 dB. Okay. There was a This is many, many years ago, back before before cell phones and before cable television and so on. And I was listening on one of the St. Louis repeaters that you guys ran. I don't remember whether it was on 9.4 or 9.7 or whatever it was. Okay, and I heard a couple of guys talking. And one of them said, if we went and put a repeater on top of the arch, we'd be able to talk to Columbia, Missouri. And I said, no, you can't. Oh, yes, you can. Oh, no, we can't. And I said, well, after we got done visiting a little bit, I said, I'll tell you what, when you get home tonight, turn your TV set to channel 13. Okay, there's a TV, this is AM, or this was analog TV back before we had digital TV. I said, go order channel 13 on your TV set. And there happens to be a TV channel 13 transmitting about halfway between Jefferson City and Columbia. And their effective radiated power is 500,000 watts. And if you can see anything on your TV set, I'll take my word back. And of course you couldn't. Okay? The problem is, just like they said when you're in grade school, the world really is round. Path loss, this free space is, this is the formula, 36.6 plus 10 log of frequency in megahertz, 10 log distance in miles. Turns out about a mile on VHF on 2 meters is about 80 dB. Power on 440 is about 90 dB the first mile. So this is why the fact that the world is round, when you're mobile and talking through a repeater, as you drive further away, the signal gets weaker. Not only does the path loss increase, but the earth starts getting in the way. If you want to solve the problem, higher antenna. Higher antenna always works better. General rule of thumb is for every time you double the antenna height above ground, you get 6 dB improvement. Darn, that 6 dB keeps coming back, doesn't it? About 1S unit or quadruple power. Of course, unless you're behind a hill. Just to give you a general idea, okay? If you are limited in money and you don't have an HOA or a city that bothers you too much, don't put the money in the amplifier. Put the money in the tower and the antenna. You'll get more out of it for the money, all right? And not only that, it helps on the receive side too. So if you're high enough, you have no earth losses. I've worked a 2-meter repeater at 100 miles away with a 2-watt HT. Of course, I was at 9,000 feet in my airplane, but it worked really good, okay? But here again, we're going to go backward. You sound like I'm beating a dead horse here, but if you increase the transmit power of your mobile from 30 watts to 60 watts, you'll increase the output power by 3 dB. This should increase the range. But as you drive away, the losses also start to go up. Okay? Not only does the path loss go up, but the world starts getting in the way. And that shoots some of the gain. Actually, it shoots most of the gain of the extra power. Since it takes a 6 dB increase in the receive signal to double the voltage, it doesn't affect range very much. As I've said, increased power increases range about a long fence post, maybe a short utility pole, something like that. Now you know why power means so little. Turn your power down and save your finals. I've got an IC 7000 in the car on HF and 2 meters and 440. And I set it, that's 100 watt on HF and whatever. And I set it at somewhere 80, 85%, something like that. Doesn't make any difference at the other end. And it must work okay, because the other morning I talked to a guy in Wales while I was mobile going around on 270. So it does okay. And to prove this to yourself, take your HT, get a mag mount, okay, turn your regular radio off and just use the HT and the mag mount. You'll be surprised at how well it works. And I've always said if signal generators were $100 and watt meters were $1,000, everyone would brag about the receiver sensitivity instead of their output power. and everybody would buy receiver preamps instead of linear amplifiers. Anybody got any questions? I'm here, quite willing to help. Somebody turn the light on. Okay. Yeah, go right ahead.
When you were talking about it would increase the power on the other side, you're talking about the person receiving your signal?
Yeah. If I'm talking to you, okay, and I'm S9 on your S meter, and I double the power, I'll go to 3 dB over S9. Yeah. Or if I quadruple the power, if I go from 100 watts to 400 watts, reach over and flip my amplifier on, I'll go from S9 to 6 dB over S9. Okay.
How important are radios?
Huh?
How important are radios?
Oh, on antennas? The general rule of thumb for the AM broadcast engineers is after 120, it doesn't matter much.
120?
Yeah, that's what's in the FCC rules, is a minimum of 120 radios for an AM broadcast station. Yeah, 1 every 3 degrees, okay? And, not only is that in the rules, that seemed to be pretty much what they do. I got a friend of mine, lives out in O'Fallon, and I told him that. He said he couldn't put 120 of them in, but he did put about 20 radios underneath his Mosley trap vertical sitting on the ground, and boy, he works out good, okay? Many, many years ago, again, many years ago, I talk about many years ago because it was, okay? Mosley,
I got 57 under mine, and I just worked.
the more you put under, the better it'll work. It becomes, every time you add one, it gets a little bit less, but as far as improvement is concerned, okay? But many years ago, Mosley made, and I still have one, I still have the book for it, a 75, 40, 20 meter trap vertical that was made out of 600 ohm open wire line and had some capacitors in it. And it's got jumpers here and there. I've looked at it a couple times. I can't figure out what it's doing. But I had a trailer out in the country, and I pounded an 8-foot ground rod into the rock, and I hooked this antenna up, and I threw a string up in a tree, and I pulled the antenna up, and man, it wouldn't talk across the street. All right, well, the law says put some antennas, some radios underneath it. So I took and put 2 75-meter radios, and I put 2 40-meter radios out through the weeds, 2 20-meter radios, and kept out of all the weeds and stuff. Boy, that antenna started to work good. So then I started adding a few more. I added some on 10 and 15, and so on. And the more copper I put down, and I was laying it on top of the ground, on the weeds, okay? I wasn't burying it. And the more copper I put down, the better that antenna worked. So yes, it does make a difference. And I learned that one, okay, the hard way, because I figured that, well, shoot, it doesn't make that much difference. If I put a good ground rod, a good 8-foot ground rod in, it'll work okay. Didn't. Okay, air-cooled dummy load. Okay.
Talk a little more on what you just touched, that you had radios that matched the frequencies you were using on the antenna.
General rule of thumb.
How much of a difference is that on a
Well, it does make some, but not a lot. The general rule of thumb is you make the radios a quarter wave long plus 5%. So if you got a 33-foot long antenna, you make the radio 16 feet. Well, if it's a half wave for 33, it'd be 16. So you're making a quarter wave. You're making it a quarter wave plus 5%. So whatever the antenna, 40 meters is 66 foot long, half of it's 33, that's a quarter wave. So you'd make the quarter wave radio 33 plus 5%, okay, or about an extra 1.5 feet. Doesn't need to be insulated. It can be insulated, doesn't need to be insulated, okay? The earth doesn't care, okay? Just the more you put under, the better it works when you're talking. And, of course, if you talk about vertical antennas, the vertical antenna with no radials underneath it, okay, has an angle about like this. The more radials you put, the lower the angle gets. The lower the angle gets, the lower the angle gets. The more radials you put under it, the better of a DX antenna it is. because the takeoff angle is going on out farther before it hits the ionosphere and bounces back. So that's basically, if you're going to do vertical antennas, the more radios, the better. What I did and have done, and I did, Larry and I have been working on vertical antennas for a friend of ours, okay, is the easiest way to do that is get yourself some wire, and hopefully you got the antenna mounted out in the backyard someplace on a piece of pipe with a good ring around it so you can hook ground radios to it. And you take a pizza cutter and you lay the wire out and you go along with a pizza cutter and you cut the grass and you reach over and you stomp the wire in and then you go stomp, 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 okay? And there's your radial underneath the wire, and all it takes is a pizza cutter. You can do it with a lot of other things, but the pizza cutter is cheap and easy and so on. So that's a good way to put radios down, just with an old pizza cutter. Okay. Yeah.
What size wire is best for radios? Is there a specific size?
Not really.
I went to a,
Go ahead.
I went to a tool store and I got a whole big roll of lamp wire.
Oh, yeah.
Split it down the center.
Yeah, I've done that. I did that in Mobile when I was doing some work up in Montana. I took and got a 65-foot piece of lamp cord, regular lamp cord, stripped it, okay, hooked it together, and I would alligator clip it to the base of my mobile whip, okay, and I just run it out. I was in the parking lot in the evenings and so on, and I just run it out, okay. If you do not have any radials, okay, underneath an unbalanced antenna, an untuned antenna, it has a tendency to give you a little RF bites. I took my radio, we went to the Bahamas one time, and I have a portable antenna that's simply a 65-foot long piece of wire, okay, with a plug on the end, and I carry some wooden clothespins with me so I can hang it on whatever I can hang it out on. And I hooked it up, and it received good, and I reached over with a microphone and started to talk and got a little burn, RF burn, and RF burns aren't any fun. Well, I had grounded it to a water pipe, but that's all sand. And I actually wound up making a counterpoise out of just whatever scrap wire and alligator clips and anything that I had, and I finally made a counterpoise for it, and then the RF burns went away. A counterpoise is simply another antenna that basically, or the other half of the antenna that just lays on the dirt.
Wouldn't a coil have taken that?
Well, maybe. I'm on vacation.
Oh, gotcha.
Okay, I'm on vacation. So I had what I had, okay. When I went the second time, okay, then I was smart, and I took all the other stuff with me, okay, and got into a place that I was able to put the counterpoise out, and it doesn't have to be under the antenna. It can just be anywhere. What it's doing is it's capacitively coupling to the world, okay, and that's enough to make it work. So, okay, yes, yeah.
How straight the radios are?
Pardon?
Does it make any difference how straight the radios are?
No. God and the radio engineers don't care.
I went to my fence line and I ran them down the
Yeah.
fence line and they worked just fine.
Yeah. You can actually, if you got a small lot, you want to go that way and the fence is only there, zigzag it. Okay, as you're going. Okay. You could, but usually you want to do it at one end. So that you could run it out to the fence and then sideways down the fence. Okay, yeah. Okay. So it's just you do with what you got. Okay, and as long as you get something down, but the more as far as radios are concerned, like I said, the AM broadcast engineers say after 120 it doesn't matter much. Okay, and that's one of the problems that's going on with the AM broadcast business right now, is so many of them have young engineers that don't understand, and they've got a problem with their radio systems. First of all, people go in and steal the copper. Okay, that's one of the first problems. Okay, and they don't understand, and the transmitting tower and ground radio system's been up there 50, 60 years, and there may not be much left. Huh?
Are they
Now, that's another story, okay? That's a completely different application. I had a fellow when I lived up in South Dakota that was a good CW op, and he took one of the Mosley trap verticals, I think it was anyhow, put it and mounted it on his chimney, and he ran 8 radials out. 2 radials for each band, okay? Now, of course, the birds going through, they had to go to zig and zag to go through all the radials. But he worked all over with that. Of course, first of all, it was on CW, so that helps a little bit. And of course, the fact that you're in South Dakota doesn't hurt a bit either. I had worked a guy one time, a long time ago. He says, "You're DX yourself." Okay.
I've heard on some QRPs now they're putting window screen underneath.
Oh yeah, if you can afford it. Yeah. Okay. What they did years ago, again, is back when copper window screen was cheap. Okay, they used copper window screen. Okay, if you can buy metal window screen that's aluminum or something like that, as long as you can connect to it properly, window screen works good. Okay, yeah.
There's a trend now for POTA stations to use Faraday cage blankets that they're inexpensive and they're very easy to take with you.
Yeah, it's basically it's what you can get at, and to be very honest, I don't know where you could go buy regular copper screen right now as far as going to a Ace Hardware or a Lowe's or something like that. I don't know where you'd be able to buy it. I'm sure you can buy it, but I'm sure you'd have to do it online. Okay, but yeah, the rule of thumb is the more copper in the dirt, the better. Run it till you can, till you either run out of wire or money. Any other questions? Everybody, thank you. Oh, go ahead.
So what do you know about the service life?
I didn't hear you.
What do you know about the service life of bare radials versus insulated?
I have no idea. No idea.
And how long have you been at Ham again? 65 years?
65 years. I have no idea. I used whatever I got. Okay? I never stayed in a house 50, 60 years, so I have no idea. I never went out unburied one. Okay? Go ahead.
Bright bronze copper wire mesh screen roll, 72 inches by 100 feet, 90% copper, insect screen for window, $1,638.18.
Come on, Hart, start back up again. Start back up again, Hart. Okay, at least it. 1,600, yeah.
Good job, Jay, good job.
Okay, thank you. Appreciate it. Catch me after. I'll stay for the whole meeting. Okay.
Anybody have anything for the good of the group? All right, then I guess we are adjourned.
Well, I don't even have to sit down. I can stand back up again.
He wasn't able to make it tonight.
I'll take that microphone from you if you're okay.
They were both, they had other.
Thank you, sir. Came in loud and clear.
Oh, we did? Good.